Section 3.6 Derivatives as rates of change. This section, we will look at position, velocity, speed, and acceleration, which are applications in physical science, and also the application in business, such as the average and marginal cost. The position function uses the notation S equals F of t. The displacement, which is the change in position between the t equals a and t equals a plus delta t, is the change of the function or the function f at a plus delta t minus f at a. An average velocity is the rate of change of the position and the time, or the delta s divided by delta t, which is the difference of the function at a plus delta t and the function at t divided by delta t. An instantaneous velocity, or v at a, is the limit as delta t approaches zero of the average velocity. Or we can say the instantaneous velocity is the first derivative of the position function at a. The speed is the absolute value of the velocity. The acceleration is the first derivative or the rate of change of the velocity with respect to time, or the v prime, which is the same as s double prime, or the second derivative of the position with respect to time. Example 1. The following figure shows the position function f s equals f of t of an airliner on an out and back trip from Seattle to Minneapolis, where s equals f of t is the number of ground miles from Seattle, t hours after takeoff at 6 a.m. The plane returns to Seattle 8.5 hours later at 2:30 p.m. Part A. Calculate the average velocity of the airliner. The average velocity is the rate of change of the position and the change of the time. In part 1, during the first 1.5 hours of the trip, or t between 0 and 1.5, the average velocity is the change in position at 1.5 and at 0 divided by the change of the time, which is 1.5 minus 0. And from the graph, 1.5, the function value is about 600. 600 minus the function at 0 is 0, divided by 1.5 minus 0 gives us 400. And the unit is the unit of the position, which is miles, divided by the unit of the time, which is in hour, or 400 miles per hour. Second part, between 1:30 p.m. and 2:30 p.m., which is 7.5 hours away from the beginning point or from the taking off time, and 8.5 hours from the taking off time. So the average velocity would be the function at 8.5 minus the function at 7.5 divided by 8.5 minus 7.5. And from the graph, the function at 8.5 is 0 because the plane already landed at Minneapolis, always come back to Seattle Airport. And then minus the function at 7.5, which is about, let's say 300. And the change of time is 1 hour. So the average velocity is negative 300 miles per hour. Part B, at what times is the velocity 0? Velocity 0, that means no change in position. Or the rate of change of the position is 0. That's between t equals 3 and t equals 5. Or between 9 a.m. and 11 a.m. Part C, determine the velocity of the airliner at noon or at t equals 6 and explain why the velocity is negative. So at t equals 6, the velocity, which is the instantaneous velocity, let's look at the graph at the position t equals 6 to find the instantaneous velocity or the velocity. We just draw the tangent line passing that point on the curve and find the slope of this tangent line. We call the velocity, which is the derivative of the function or the position function, and the derivative is the same as the slope of the tangent line. And we pick the two other pairs on this tangent line. The first point is a common point of the line and the curve, where t equals 6. The position is 1200. And we pick another point, another convenient point. Let's say if we pick this one, which is the other pair 7, 800. So the slope of the tangent line is the second point position, which is 800, minus 1200 divided by 7 minus 6. That gives us negative 400. The unit miles per hour. And what does it mean? You have the negative sign. It means the direction of the plane is in opposite way. Or we can say the plane is on the way back to Seattle.